Hi all, this is Les Hoffman and I would like to demonstrate the 5 principal components of a subtractive synthesizer. First of all, you need an oscillator. That's the signal generator. And in this case, we have an oscillator up in the upper left corner. And at this time, I have a frequency of 500 Hertz, and we're going to show what it sounds like as a sine type of wave, which is the cleanest, most fundamental type. Let's get the Okay, you can see that it's principally just one on the spectrum display. It's only the fundamental. The sawtooth, on the other hand, is a lot more piercing sound, bright sound. It has a large range of odd and even harmonies. The triangle. Okay, well, let's go to the square, which is a more woody and hollow sound, with a wide range of odd harmonics. And finally, for the triangle, it's a flute-like. It only has the odd harmonics, and you can show those if you bring the signal up a little bit here. Okay, so that's the first component. That's the oscillator. And now we're going to get to the filter, which removes part of the signal that's sent from the oscillator. For example, you can take a sawtooth signal and make it a little bit more warm sounding by cutting off the higher frequencies with a low pass filter, which is the most important type of filter for a synthesizer. So let's generate a saw, and okay, I'm now going to put the low pass filter on, and you'll see it becomes much more pleasing sounding. And you're also in the lower right in the spectrum display, you can see that you're cutting away some of those upper harmonics too. Okay, so now we have the envelope, which is the control for, you can think of it as a keyboard control. It controls how fast the key goes down, how long it stays sustained, and how long the tone remains after releasing it. And we can change these levels here. The most important thing to remember is that the attack time and the delay time and the release time are all time controls, whereas the sustained level gives you an actual level at which it's sustained. So attack time, decay time, this decay, and the release time are times, whereas sustained level is actually an amplitude. Okay, so now, of course, you need an amplifier to produce all this sound. That's basically controls the loudness of the signal over time. And here is a gain control here. Turn it off. You can see. You also, as you get to higher volumes, you bring up the harmonics here. So let's go back to the envelope. And well, what happens now if we turn off the signal and turn it back on? You'll see that it emulates the amplitude envelope settings here. Okay, we'll turn it back on. You get the rise for the attack time, decay time, you get the sustain level, and when I turn it off, you get the release time. So it pretty much emulates what's shown in this diagram. Finally, let's talk about the low frequency oscillator. This is something that's not usually audible because it's too low a frequency to be heard. I have this set about 3 Hertz, and what this can do is add something like vibrato or filter sweep effects. And it gives you the sort of sound that you get from a violin played with vibrato. Let's put on our signal here at 500 Hertz, and I'll show you what happens here when I put on this low frequency oscillator. Yeah, you get a vibrato effect, and you can actually do it in other waveforms like square, which gives it really sort of a on and off button sort of effect. I think it's more pleasing with the sine. Okay, so I've gone through the principal components, everything except for the amplifier here, really, and I'll just demonstrate at the end here on a sine wave. if you bring that amplitude too high, you start clipping. And even on a sine wave, you'll start seeing some secondaries, some higher harmonics coming out of that. So, this has been fun showing you the principles of a simple synthesizer. And those would be, of course, the oscillator, the filters, the envelope, the amplifier, and the low frequency oscillator. I look forward to hearing and seeing your presentations.